Back to our next lesson here in using the quadratic formula to solve quadratic equations. Recall that we are in Module 3, which is all about quadratic formulas and quadratic equations, and this lesson 7 here specifically deals with using the quadratic formula to solve those quadratic equations. Remember, we looked at a bunch of different ways so far to solve quadratic equations. We talked about solving using square roots. We talked about factoring using the zero product property. And also we talked about completing the square, which then has us use the square roots too. Okay? All right. Let's use this quadratic formula here because that's what this says. Now, this problem here, if you look at it, it actually factors, but we won't factor it. We'll use the quadratic formula like they ask us to. Okay? So in this case, our A is 1, our B is -2, and our C is 1. So go ahead and fill in the quadratic formula. Try that on your own here. Okay, again, here's the quadratic formula right up here for you if you need it. Okay. All right, hopefully you did that. Here's how we fill it in, right? So it's going to be x equals, and so it's going to be -b, so it'll be -2, because b is -2, plus or minus the square root of b squared, so -2 squared, minus 4 times a, which is 1, times c, which is also 1, all over 2 times a, which is 1. And now we just simplify. -2 becomes +2. -2 squared is 4. 4 times 1 times 1 is 4 over 2. Now what's 4 minus 4? Well, that's 0. So we get 2 plus or minus the square root of 0 over 2. And what's the square root of 0? What number multiplied with itself gives you 0? The answer is 0. So we get 2 plus or minus 0 over 2, which is really just 2 over 2, or 1. So that's interesting because we add or subtracted 0, right? We only get one solution there. Okay, so this number underneath the square root, when it is 0, you're only going to end up with one solution. So x equals 1 is the only solution here. Okay, which should make sense if we actually factor this thing. It does factor. Two numbers that multiply to +1 but add to make -2 will be x minus 1 and x minus 1. You can see if we set both of these equal to 0, they're both going to yield the same answer of 1. Okay, so that 1, even though it looks like it's only one solution, it's really like the same solution twice. Okay, all right, let's try another one here. Okay, 3b squared plus 4b plus 8. Now in this case, our a is 3, our b is 4, and our c is 8. So x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times, a, but we know what a is, it's 3. And so we simplify. So you get -4 plus or minus the square root, so this will be 16 minus 4 times 3 is 12. 12 times 8 is going to be 96 over 6. Okay, and now we simplify further. So 16 minus 96, that's going to be a negative number, right? So 16 take away 96 is going to be the square root of -80 over 6. Okay, now we haven't done a whole lot with imaginary numbers here, but this is a situation where we have an imaginary number because we are taking the square root of a negative number, and so and let's take a little sidebar over here. We'll do it over here. So the square root of -80 is equal to the square root of -1 times the square root of 80, like this. This is an imaginary number, so we'll call that I. Okay, I is just equal to the square root of -1. And we can simplify the square root of 80 now like we normally would. So let's see here, we can take out a 4. Actually, let's take out a 16. That's 16 and 5. Okay, and so we get 4i root 5. And so then this just becomes, because again that square root of 16 became the 4, the I stays, right? And then the root 5 we can't simplify any further. And so we get -4 plus or minus 4i square root of 5 over 6. And we can simplify these here too. If we do -4 over 6 plus 4i root 5 over 6, we can simplify these numbers. 4 divided by 6 becomes 2 over 3, and 4 divided by 6 becomes 2 over 3 again. So it's -2 over 3 plus or minus 2i root 5 all over 3. Okay, so there's our answer. All right, next, quadratic formula again. Go ahead and try it on your own. what's your a, b, and c, and then plug it in the formula and try and simplify. Pause the video and do it. Okay, hopefully you pause the video here. So there's our a, there's our b, there's our c. So a is, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we get negative 7 plus or minus the square root of 49. And then let's see here, negative 4 times 2 is negative 8. Negative 8 times negative 4 is positive 32 over 4. And so let's see here, we get negative 7 plus or minus, let's see, 49 plus 32, 51, 81 over 4. Okay, so we get negative 7 plus or minus, square root of 81 is 9. So this is a perfect square. We're going to get two nice real answers here. So that means we'll have negative 7 plus 9 over 4 and negative 7 minus 9 over 4. And so we get then 2 over 4, or just 1/2, because negative 7 plus 9 is a positive 2. Or negative 7 minus 9, which is negative 16 over 4, which gives us negative 4. So those are our two answers. X equals 1/2, x equals negative 4. All right, squeeze in one more here. Q squared minus 2q minus 1. Again, pause, try this one on your own. Okay, so a is 1, b is negative 2, c is negative 1. So x equals negative 2 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And so we'll simplify. Negative 2 is 2. Negative 2 squared is 4. Negative 4 times 1 times negative 1 is positive 4. And so we get 2 plus or minus the square root of 8 over 2. Okay. Root 8 is not a perfect square, but it can simplify. What perfect square can we divide out of 8? The answer is 4. So we get 2 plus or minus 2 root 2 all over 2. 2 can't be broken down any further. There's a square root, so we know we're done with that one. But we can simplify a little bit further if we go 2 over 2 plus or minus. So we'll break up this, break up that. Okay, so it's 2 over 2, so we get right there, and then 2 root 2 over 2. Like so. Which simplifies to 1, and then 2 and 2 cancel out to just root 2. So 1 plus or minus root 2 is our answers there. So q equals 1 plus root 2, q equals 1 minus root 2. Just like that. Okay, and we'll do this last one here. So this one, okay, right, it's not quite in the right form because we need it to be equal to 0. So how are we going to fix that? Well, we'll just subtract 3 from both sides. We get m squared minus 7 equals 0. Okay, now we're making this way more complicated using the quadratic formula. A really easy way to solve this would be using the square root if we just add 4 to both, or a much faster way, I should say, not easier way, but faster way. We'd be solving using the square root. So we add 4 to both sides, we'd have m squared equals 7, and we get the square root. But the directions ask us to use quadratic formula, so let's do that. So let's see here. A is 1. Our b is, well, we don't have 1. So really the b is going to be a 0 because there's no m. There's 0 m's, right? Just there's an m squared, but there's no m's, so it's 0m. And then, of course, the minus 7 here for the c. So x equals negative 0 plus or minus the square root of b squared, so 0 squared minus 4 times a times c all over 2 times a. So negative 0 is just 0, so we're going to have 0 plus or minus the square root. 0 squared is 0, so 0. Negative 4 times 1 times negative 7 is positive 28 all over 2. And so we're going to get plus or minus the square root of 28 over 2. 28 we can, are there any perfect squares we can take out of 28? And the answer is yes. We can do 4 and 7. So it'll be root 4 and root 7 like that. That's the same thing as root 28. Square root of 4 is 2. So you get plus or minus 2 root 7 over 2. The 2's can cancel. You get plus or minus root 7. So there's our answer, which again we would have gotten if we had just used square roots. If we added 4 to both sides here instead, we would have gotten m squared equals 7, and we just square root both sides to get m equals plus or minus the square root of 7. So you can see here that you really just don't want to blindly use a quadratic formula here. Okay, this only would have taken 2 steps if we used the square roots, whereas we had to use all this mess for the quadratic formula. Okay, see you next video.